All right, everybody. Guys, is my voice fine? Everyone can just let me know quickly. Let me know, guys. Okay, it's clear. Saifullah, you could just rejoin the meeting and let me know if the voice is clear or not. या फिर मैं जल्दी से देखता हूँ बाहर अगर मेरे कोई और डिवाइस को मैं डिस्कनेक्ट कर लेता हूँ फोन को भी डिस्कनेक्ट कर लेता हूँ Acha, maybe it's due to Muharram too. The internet access nowadays has been like really the access amount of internet and the speed it's like really low nowadays, and so maybe because of that आपको थोड़ी सी lagging या कोई वो वाला scene हो रहा हो. But चलो, let's start off officially. Bismillahirrahmanirrahim. Okay, guys. So in the last class we ended it with the discussion of adding binary numbers. This was the very last thing. How do we add two positive 8-bit binary integers? Okay, we discussed the concept of overflow. How do we add numbers in binary addition? And also the other, like we discussed a lot of questions related to how we can do it. And we discussed this simple shortcut to it, that if you have no ones, the answer and carry both are going to be 0. If we have a single one, just bring the 1 down. If we have 2 ones, the answer is going to stay 0, whereas the carry is going to be 1. If we have 3 ones, the answer is going to stay 1 as well as the carry. So now, as we're done with this, there is an important thing which you all need to understand. Oh, sorry, I just forgot when chatting you. Okay, so there is an important concept. Till this very moment, we have only discussed positive binary numbers. Okay, what do I mean by positive binary numbers? By positive binary numbers, I basically want to say that, like, to this very moment, whenever we were trying to turn any denary number or a base 10 number system into a base 2 number system, our numbers were always going to be like 1, 2, 4, 8, 16, 32, 64, 128. And then we could like put 0, 1, 0, 0, 1, 1, 0, 0, or numbers like that. But the issue with this is that if you see all of these numbers are positive, but it's not only positive numbers that we are dealing with, right? We do have negative numbers in existence too. Like maybe I say that I have 75 plus minus 23. So how am I going to be telling the computer that I want to deal with negative 23? Now that's the concept we are going to be studying today. Because if I try to plot a 23 on this, what would it be? It would be a 0, 0, 0, 16. 16 plus 8 is what? 24. So it's going to be 0. 16 plus 4 is 20, 22, and 21. But the issue with this is that this is basically positive 23. I don't need a positive 23. We all know there is a difference between plus 2 and a minus 2. 10 plus 2 is going to be giving me a 12, whereas 10 minus 2 is going to be giving me an 8. So there's a difference between the two, and we need to take this into consideration. But now we need to understand, how can I tell the computer that I will be dealing with negative numbers? That's the concept we are going to be studying today, and it's known as the 2's complement. 2's complement. 2's complement. So 2's complement is basically the basic mechanism behind how we can tell the computer that we need to be storing negative values. Now, if you see and if you look at this specific numbering 1, 2, 4, 8, 16, 32, 64, 128, this is an 8-bit denary register, right? We have numbers from 1 to 128, and we can like store 1, 2, 3, 4, 5, 6, 7, 8. So we have like 8 slots in a big register, and we call this an 8-bit register. Now, there is a catch to it, guys. If you look at this specific number, the maximum value, if I, let's say, assume that if I put ones in all these numbers sections, like let's say a 1, 1, 1, 1, 1, 1, 1, 1, what's the answer I will be getting? I'll be getting a 255. Let's quickly do it on the calculator too. Okay. Let me just do it on the calculator so that we could check it and confirm. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And you guys see, I got a 255. This means that a maximum value, max value for an 8-bit register, okay, remember it's only 8-bit register, is 255. But this 255 is what? It's positive 255. I need to find something where I can also deal with negative numbers too. So there are basically two methods to it. The first method is known as the 2's complement. Now, what happens in 2's complement is that we are going to be writing the same values number first. Like I will be having 1, 2, 4, 8, 16, 32, 64. But rather than writing positive 128, I will be saying that the most left hand side bit will be a negative 128. Now, there is another thing which I missed recently, which I was just overlooking some questions and it came to my mind that this number, the most left number, okay, the most left number, let me write it up here. The most left number, this is basically known as the most significant bit, is called the most significant bit. The most significant bit. So your most left bit, whatever binary number you have, the number which will be at the most left hand side will be the most significant bit. So now this number is basically most significant, okay, which means that this number has a lot of value. Why? Because usually when we are dealing with positive and negative numbers, we have to always change the most significant bit, which is the most left side bit. So what's the most left number? It's this one, okay. So I'm just converting the positive here to what? I'm converting it to a negative. So I have a negative 128 right now. And just like that, it's important to understand that this number, the most right side number, the most right side number is called the least significant number, okay, is called the least significant bit. So we have the most significant bit, which is the most left side number, and then we have the least significant number, which is, or the least significant bit, which is the most right hand side bit. So this one, basically the one, this is basically your most least significant. Now if I look at this binary number, let's say this one, that this number 9. So in this, the most significant bit is basically going to be this one, the most left hand side, and this one is going to be the least significant one. So it's important to understand this, but perhaps leave it. We will discuss that in question later on. I should not be confusing you. Now, coming to the main concept, you guys know that the most left-hand side number is known as the most significant bit, right? So if it's the most significant bit, I'm going to be changing this positive. Okay, guys, a few of the people joined in just now, and I would like to give you all a quick recap. We are just discussing positive binary number. We discussed positive binary numbers previously, and now we are just going to be looking at how we can tell the computer to write negative binary numbers, because we have to deal with values such as negative 23 rather than only dealing with positive 23. So the method to including such negative numbers is, firstly, there are two methods to it. The first method is known as the 2's complement number. So in what happens with 2's complement is that when we are usually dealing with binary numbers, we have the concept of putting values that goes from 1, like up here 1, to a positive 128, right? 1, 2, 4, 8, 16, 32, 64, 128. Now what happens with 2's complement is that we shift the positive 128 to a negative 128. Why do we shift only the 128 number? Because it's known, it is basically the most left hand side number, right? So the most left hand side number is always known as the most significant bit. It has the most value. So we are going to be converting the most important bit to negative. Now let's say I have this as negative 120, and I'm going to be writing the values as, let's say, 1, 2, 4, 8, 16, 32, 64, negative 120. Now let's say I want to portray something like negative 20. How am I going to be putting a negative 120 up here? The first and foremost thing is that whenever the question says 2's complement, whenever we are dealing with 2's complement, your most 8-bit, this 8-bit will always be a minus 128. We won't be dealing with positive 128. Remember, if the question clearly says, let me write it. If the question says 2's complement, it's important. The keyword here is 2's complement. If the question says 2's complement, know that we will be having a negative. Know that we will have minus 120. Okay, so we will be having a negative 120. And what's the keyword to look for? It's 2's complement. If the question doesn't talks about 2's complement, if it's just talking about binary digit, then just assume that it's going to be a positive 128. But because the reason behind this is that if the question says, let's say we are dealing with 2's complement numbers, there is a possibility that they still give you a positive number, but you need to write it in terms of 2's complement. Now let's say I want to write positive 20, positive 20. How will I be mentioning positive 20 up here? So the first and foremost rule, whenever we are dealing with negative numbers, if the minus 128 bit is a 0, this means it's positive. And whenever we need to deal with negative numbers, we are going to be keeping this a 1. Now, I will be coming to the reasoning behind this, but let's say I want to like plot 20 onto it. So 1 minus 128 is going to be a 0, 64 will be a 0, 32 is going to be a 0, 16 will be a 1, and then a 4 will be a 1, and the other will be 0. Now this is what? This is positive 20. But now let's say I want to do negative 20. How am I going to do that? So for negative 20, it's important. First of all, turn on negative 128. It's going to be 1 under the minus 128 thingy, but perhaps why not write it again? Minus 128, 64, 32, 16, 8, 4, 2, 1. So we will have a 1 up here, which means that we are dealing with what? Negative numbers. Now we are dealing with negative numbers. Now what's the concept behind this? It's basically the same. Like what did we do up here? We were adding the numbers, right? We had a 16. Now 16 plus what is going to be a 20? It's going to be a 4. So we just put a 1 up here too. Now the same concept is going to be repeated up here. We were going to be having negative 20, right? The answer should be negative 20. Now we have minus 128. Now minus 128 plus what number is going to give me a minus 20? That's the main game which we need to find right now. So as I mentioned again, your mental skills need to be really, really good when you are dealing with such binary numbers, because you don't have a calculator allowed in your exam. Okay, now I need to get an answer which tell me, like, let's say I need to add something into minus 128 that gets me the answer as negative 20. Now what's going to be that number? It will be basically it will be 108. So if I do minus 128 plus 108, I will be getting minus 20. Now I need to be basically plotting 108 up here. Now let me just confirm whether the value number was a bit big or can be plotted. We can plot it. So how am I going to be plotting? Yes, exactly, Ahmed. Perfect. We need to plot 108. Now, how am I going to be plotting 108 on this very specific scale? That's the question. 64 on or no? Yes, definitely on. 32 on or no? 64 plus 32 is what? It's 96. So yes, definitely. 92 plus 16. Now I will be using a calculator, but it's 96 plus 16 is what? It's 112. No, it will be an off. We won't be turning this on. Rather than that, 96 plus 8. Yes, definitely. Why? Because 96 plus 8 is what? It's 104. 1. And then 104 plus what is going to be giving me 108? It's going to be a 4. So 0, 0. Now this binary number 111011100 is basically giving me the answer minus 20. Now this is minus 20. Now why is it important to understand that that we have to look for the 2's complement keyword? Because if we ignore the 2's complement keyword, and let's say we are just dealing with normal binary numbers where we don't have such 2's complement word mentioned in the question, then the answer to this will be very different. Because in that case, what's the error mostly kids make is that they count this minus 128 as a positive number, and if you count this as a positive number, your answer is going to be 128 plus 64 plus 32 plus 8 plus 4. So just add this up and you will see that you get the answer as 128 plus 64 plus 32 plus 8 plus 4. You get it as 236. Now, what were we trying to find? We were trying to find a minus 20. What did we get? We got a 236. It's 100% wrong. Why? Because we ignored the concept behind 2's complement. This is the most important keyword. Your question is clearly going to be mentioning either negative numbers. If it either says negative numbers, know that we need to be going with 2's complement method, or otherwise it's going to be mentioning the word 2's complement in it. So either way, just know if it's either 2's complement or negative numbers, we need to be making the most significant bit a negative one, which in most cases in your O levels is going to be the minus 128 bit. So you're going to be turning on, shifting this positive 128 into a negative 128, and then we will be turning it on so that we could deal with negative numbers. So is it clear to this very moment? We're going to be doing other questions, but did you guys get this example? Let me know quickly. Perfect. Now let's do one other question, guys. Let's do some other questions. Let's say We are going to be finding for both. Okay, we will be finding for both the numbers. Let's find positive 16, and then let's also find negative 16. Now, if I want to find a positive 16, okay, positive 16. So we are going to be using the same method which we have been using to this very date, till this very date. It could be used even if we have 2's complement, but we are dealing with positive number, it's going to be the same thing. There is no difference at all. Why? Because let's say I will do it with the 2's complement method, okay? We have around 7 to 8 kids registered. The other kids are going to be added into the group inshallah by tonight. So let's see. So 1, 2, 4, 8, 16, 32, 64, and then finally minus 128. Let's say we use the same 2's complement method to plot a positive 16. But now let's say we have a positive 16, right? So what am I going to do? I will be putting minus 128 as a 0, because I need to deal with what? Positive number. And then 64 is going to be 0, 32 is going to be a 0, 16 will be a 1, and the other numbers are also going to be, perhaps let's make it 17. This is very, very easy. 17. This is also going to be a 1. So again, 1, 2, 4, 8, 16, 32, 64, and negative 128. Okay. So now we have 0, 0, 0, 1, 0, 0, 1. Now this is positive 17. Now even if I count this specific number as positive 128, it's still going to be a 0. So when dealing with positive number, there is no difference. No difference. Because either way, we keep this minus 128 as a 0. Now there is an exception to it. Usually when you are dealing with such numbers and the question says that you need to deal with 2's complement number, it's important to understand that your range is going to reduce. What do I mean by range? By range, I mean that the question won't be giving you something like, tell me, how do we find, like, what's the maximum number we can get? Just a second. 16 plus 8, 4, 2 plus 1. So the maximum number we can get now is 127. So now when we are dealing with basically negative numbers, it's important that the maximum largest number when you are using 2's complement is positive 127. So it's going to be positive 127. Whereas what's the largest negative number we can get? It is to negative, let's say negative 127. So your range, this is the range symbol. Okay, perhaps make it like this. You can go from a positive 127 to a negative 127. So this means that we could have, guys, just a moment, just a second, guys. Yes, sorry guys, sorry for the disruption, but let's get back to where did we leave. Yes, so I was just talking about how our maximum range is positive 127, and then the least number which we can include is what? It's negative 127. Now how did we get this? But there's just know that this is only for the 2's complement. Why am I mentioning 2's complement again and again? Because when we are dealing with 2's complement, we have this as a negative number. But if we are dealing with normal numbers, we are going to be having this number as positive 128. So we have it as 2's complement right now, right? So the positive number, greatest positive number which I can get is a 127. How am I going to get that? I'm just going to be turning all of these numbers as 1, and I'll be keeping this as 0. Now, if I add all of this, I'm going to be getting a positive 127. And likewise, if I want the greatest negative number, what will that be? It will be a 1 up here, and I will be just keeping all the other. Oh, if I keep all the others 0, what's the negative number I'm going to get? It's going to be 128. So this means, in which question? No, where do you mean, like, how will be the 2 0? I'm just giving an example right now, right? So let 17. So get, like, see, have a look. What's 17? 17. If I want to plot 17, the 2 is going to be a 0, because if I move from this, it's going 128 is going to be 0, right? 64 will be a 0, 32 will be a 0. Why are they 0? Because definitely they are greater than 17, so we can't include them, right? Then we have a 16. 16 is lower than 17. Should I be including it? Yes, definitely. Now if I include 16, then what number will I be adding into 16 that I get the final answer as 17? You need to think it like this way. What number should I be adding into 16 so that I get a 17? the number is 1. It's not 2, right? So I will be turning off the other digits. It will be a 0, 0, 0. And I will be only keeping 1 under the 1 value so that I can get a 17. Now, I would have put a 1 under the 2 if the question was 16 plus what number will be giving me an 18. Now, if I wanted to plot 18, then I would have this number as 0 and this could have been a 1. But no, that's not the case right now. What do we need to plot? We need to plot a 17. Now for 17, 16 for plus what number is going to give me a 17? It's going to be 16 plus 1. 16 plus 1 is basically 17. So I will be keeping this one number as 1 and the 2 value will be a 0. I hope this is clear. Okay. So yeah, I was mentioning that I wrote minus 127, right? Minus 127. But if you look at this, now we have a negative 128, right? But minus 128 plus, let's say, no number. We keep all of this as 0. Plus 0 is what? It's minus 128. So just to make a small correction, an error I made up here, it's not minus 127. It's basically minus 128. So the smallest negative number you can get is minus 128 in 2's complement. And the greatest number you can get is positive 127. Now you do get MCQs on this. It's really important. You guys should memorize this. Memorize the range. Memorize the range. The range. Important thing here. Okay. Now let's plot the negative 16. So how am I going to be doing that? First of all, when dealing with negative numbers, remember minus 128 needs to be what? It needs to be a 1. Solid, firm 1. Now we got this as 1. Now I will be thinking, sometimes what happens is that people just add 1 and 1 and it's like pretty confusing. An easier method to this is basically doing it a bit like mathematically. How am I going to be doing that? So I will be writing minus 128 plus what number? Perhaps let's say you guys are studying maths, right? So let's say minus 128 plus x is negative 16. And if I shift the 128 to the other side, it comes as positive 128 and then a minus 16. Now what's 128 minus 16? Now this way it's much more easier for most of the kids. So if I do it like minus 121 positive 128 minus 16, I get the answer as x is equal to 112. Now I need to plot this. I need to plot this while keeping minus 128 as 1. Now how will I be doing 112? Let's do it with the blue pen, right? So I need to plot 112. Will 64 be on? Yes. 64 plus 32. 96. Yes. 96 plus what number will be giving me 112? Do it this way. 112, 96. Do it. Can we subtract it? No, we can't. So I will be taking a carry. This will be a 0 and this will be a 1. So 12 minus 6 is what? It's 6. Basic maths. Again, 0, I don't have a slot. So this will be a 0. I take a carry. 1 minus 9 is what? 10 minus 9 is what? It's 6, 1, 16. So this means I need to plot 16. Now, do we have a 16 up here directly? Yes, we do. We have this as a 16. So I will be just keeping this as 1 and the others are just going to go as 0. So I get the final answer as 1, 1, 1, 1. 0, 0, 0, 0. Now this number is basically denoting negative 16. But at the same time, this specific number, the one which we wrote above, this one is positive 16. Now you see there is a difference between the two values. So we have this as the positive 16 and then we have this as the negative 16. And there's a big difference in the binary values. Now if someone mistakenly writes this as their answer, do you guys think he or she will be getting marks? No, not at all. There is a big difference. Like look up here, you have 4 ones at the start and then you see we have 3 zeros at this side. So that's the basic concept of how you can convert positive numbers into negative numbers in the binary form. Now, is this method clear? The 2's complement method. There's one other method to it, which we are going to be discussing now. And then it's your choice, your call, whatever method you want to use. Okay, I'm trying to be explaining both the methods and then you can go with whatever you love. Okay, is it clear till this very moment? Guys in the chat. Okay, good. So we discussed the 2's complement method, right? But there is one other method to it too, guys. My camera just got off. I don't know why, but you know, it's back. So there is one other method to doing this question too. And that is something which most people find easier. Okay. Now, what will I be doing in that case? Step number 1. Step 1. Write positive binary of that number, right? Positive binary of that number, binary of that number. Let's say, give me a number, quick guys, give me some number, random number, quickly. No, 207 is a very big number, something smaller, less than 100. Remember, remember, Ahmed, you just said 207. But did you forget that when we are dealing with positive and negative numbers, we have the range from positive 127 to negative 128. So 207 is either way, we cannot plot it on this specific scale because it's out of the range. It's important to understand that whenever you're dealing with positive number, it's going to be positive 127. And if we want to plot some negative number, it needs to be less than negative 128. Guys, there is some issue with the internet today. I really apologize for that. I believe it's because of Muharram. Due to Muharram, they have reduced the what do we call it, bandwidth to all the devices. I believe, or there is some issue. But if the screen gets stuck at any moment, just let me know. I will quickly repeat whatever I was trying to explain. So the first thing, let's take the number as 72 as per Rayan. Okay, so Rayan suggested 72. I want to plot 72. Okay, how am I going to be plotting a 72? Firstly, 1, 2, 4, 8, 16, 32, 64, 128. Well, okay, as I said, positive, keep this as positive 128. Okay, keep this as positive 120. So this will be a 0. 64 on or no? Yes. 64 plus what is going to get me a 72? It will be 64 plus 8, right? So this will be a 0, this will be a 0, 8 will be a 1, 0, 0, 0. Let's confirm it. 64 plus 8. 8 plus 4 is what? It's 12. So 2, 1 carry. 6 plus 1, 7. Always calculate your answer this way. It's important. Sometimes our mind is like, oh, it's this, but you make a minor mistake and then you lose all your marks. So we don't have to take risks. Important factor. Now, step number 2. Step 2. Invert the digits. Invert the digits. What do I mean by invert the digits? By invert the digits, I basically mean shift 0 to 1 and 1 to 0. 1 to 0. Let's say we have 0, 1, 0, 0, 1, 0, 0, 0, right? So let's shift this 0 to a 1, this 1 to a 0, this 0 to a 1, this 0 to a 1, 1 to a 0, and then 1, and this 0 to a 1, this 0 to a 1. So what did I do? I basically shifted all the zeros to ones and I shifted the ones to zeros. So I inverted or I flipped. This could be named as flip 2. So flip or invert the digits. You can either flip it or invert. It's the same exact thing. So I shifted those zeros to ones and ones to zeros. So now this is clear, right? 1, 0, 1, 1, 0, 1, 1. Now we discussed previously the word 2's complement. Now this thing isn't in our course explicitly, but do know that this stage, this specific stage, this value, once we invert the positive binaries digit, this is basically known as 1's complement. Okay, so this digit, usually teachers do teach this in the school. So if in your school they talk about 1's complement, remember 1's complement referred to the binary number, which is basically the binary number in positive number followed by its shifting or inversion of the digits. So I got this as the positive number, positive, and when I flipped it, flip. When I flipped it, I get this number, which is basically the 1's complement form. But this is not the answer. There is a third step to it. Step number 3. Step number 3 is add 1. How am I going to be adding 1? Remember, last week we studied addition of binary numbers. So let's say I write 101101111 and I add 1 onto it. What's the answer going to be? Remember the code 1 plus 1 is what? Let me just write it up here again. 0, exactly, 1 plus 1. If we have 0 ones, the answer and the carry both are going to be 0, right? It's going to be 0. If we have 1 single one, the answer is going to be 1, carry is going to be 0. If we have two ones, both the answer is going to be 0, carry will be a 1. If we have 3 ones, both of them are going to be a 1. Now 1 plus 1 is what? It's 0 with 1 carry. Again, 1 plus 1, 0 with 1 carry. Again, 1 plus 1, 0 with 1 carry, 1 plus 0. Now, 1 plus 0 is basically answered 1, and then you have no carry, right? So when we have no carry, the simplest terrain, wow, guys, what logic, Urdu bhi gusa raha hoon, but the simplest way to do this is basically bring down the numbers. So it's going to be 1, 1, 0, 1. So this number is basically negative 72. Now, this is the method. Now, this is negative 72, and this is basically your 2's complement. 2's complement. Now, why not we check our answer using the method we did earlier on? Remember the other method we discussed? We had 1, 2, 4, 8, and we had 16, 32, 64, and then we had a negative 128. First thing, look at this. The most left hand side or the most significant bit is a 1 up here, which is 100% correct because we also have to put this as a 1, right? So now minus 128 plus x is going to be giving me a 72, negative 72, right? So what do I need to put up here so that I get a negative 72? It's going to be x. If I shift this 128 to the other side, it becomes positive, right? So 128 minus 72. Quickly do the mental math or just solve it like this. 128 minus 72. 8 minus 2 is what? It's 6. Then 12 minus 7 is basically what? It's 5, right? But if I do it the way we were taught, it was basically we don't have 2 minus 7. We can't do it, right? So we take a carry. This is going to become a 1 and this is 12. So 12 minus 7 is what? You do it like 7, 8, 9, 10, 11, 12. Oh, it's 5, right? So we write it as 5. So we get the answer as 56. So I need to plot 56. Now let's plot 56 up here. 64 is going to stay as 0, right? 32, yes. 16, yes. Why? 32 plus 16 is what? 32 plus 16 is 6 plus 2, 8. 3 plus 1, 4. So we get 48. So now 48 plus what number is going to give me a 56? 48 plus 8 is going to get me a 56 because 48 plus 2 is what? 50, and 50 plus 6 is basically 56. Now if I put a 1 up here and then these numbers are going to be 0. Now this number is what? It's negative 72, right? Now look at this number. This binary digit is exactly identical to this. 10111, 10111, 000, 000. So we got the exact same answer, which means that both of the two methods are 100% correct, and both the methods are going to get you the same answer. Both of them are correct. Now it's your choice. Again, it's your choice whether to go with method 2. Let me write this up here. Method 2. This is method number 2, whether you want to go with this or you want to go with the conventional method number 1. Method 1. It's your call. No, the question won't be stating something like this. You can do either way. Both of them are known as 2's complement because in the first one you have minus 128, and in the second one, once you add 1 onto it, you get the 2's complement value again. So it's the same identical thing. Did you guys get the concept till this very moment? Like, did you guys get both of the two methods or not? Good. Rayan got it. Guys, बाकी बताओ जल्दी जल्दी जल्दी. If it's not clear, no worries at all. We have a lot of time. आज हमने यही करना है. We won't be going into any other topic right now. We will be just doing this. We will be doing. No, it's not necessary to double check. Not at all. You guys won't be having a lot of time in your exam, but it's important. It's important that you go with the method which you find easier. Now, for me, like for someone like me, I personally like the method number 2. Why did I like method number 2? Because it's easier to plot positive numbers, and then it's easy 72 binaries, and then I'm going to just flip it, and then I will be adding 1. Now, this is a much easier method than going with this longer method where I need to be first doing some mathematical stuff like this. Minus 128 plus x is going to be minus 72, and then I will be getting this specific number 56, and then I will be doing this. But again, this depends. Okay, for some people this method might be shorter and it's something which they find easier. Go with the method which you find easy. Both of them are going to be giving us the exact same answer. Now let's do a few questions, right? We should be doing past paper questions. Past paper questions are really, really important. And if you're not practicing past paper questions, you're just wasting your time. But not right now. Let me just see. I downloaded it somewhere up here. Okay, let's do this question. First of all, a very, very cool question. This question is related to, let me Just write it up here that we are going to be doing past paper questions. These are past paper questions. Now the first question is related to logical shift. Remember, we studied logical shifts: logical shift left, logical shift right. Um, Ahmed, did you get my point about the double checking, or do you want me to explain? Okay, good. So now, the first question is about logical shifts. Let's read the question together. A value is stored as a binary number in a register. This is a register which has these 8 numbers. Okay. A logical right shift of 3 places is performed on the binary number. Remember, what did we study? Right side pay. This means start from the most left bit, and this is firstly, this means that if it was a one place right here, it would have gone to this place, right? If it was a 2 places right here, it would have went to this place, but it's a 3 places. This means this zero is going to go to this specific section. This will be a zero. And once we do the first element, the easier method is just write the numbers after, because this one is going to also, it will go from, like, let me get this highlighter. This one will, it won't go to this section. It, oh, no, that's not good. It's got off. Let's do it with a pencil. This one won't come up here. This won't come up here. It will go to this specific slot. So we get it as 0 1, then this one, then this one, and finally this one. Now, if you see, all of these are lost. Remember, I told you that we are going to be losing values. Now, these values are lost. Okay, these values are what? These are lost. We don't have to look at them at all. We're just going to be ignoring them. And then at the most left hand side, remember, what did I teach you all? When we have empty slots left, we are always going to be adding zeros to it. So we will be having a 0 0 0. Now the question says part 2. Did you guys get the part 1? How did I get this 0 0 0 0 and 4 ones? Guys, can you see my screen or not? How, Jaldi? Is my screen clear? Okay, good. Saifullah, maybe there is some issue with your internet. Maybe you can just leave and rejoin the class. Maybe that way it's better. And the recording will be posted. So if you don't get anything, yeah, sure. Why not? Why not? Can you see the question right now? Okay. Yeah, bataya karo if you guys can't see it or there is some sort of issue. Okay. So now this was basically the first part, right? Can you complete the binary register to show its content after this logical right shift? So I just performed a basic right shift and I get 1 mark. Now it says state 1 effect this logical shift has on the binary number. Now, if you remember, we discussed one thing. When we perform a single logical left shift, what's going to happen? The value will get multiplied by 2. It's going to get double. But if I perform a logical shift on the right side, what's going to happen? The value will get halved. It's going to get divided by 2. Now, right now, it's saying that the value, there was a shift of 3 places, right? 3 places. 3 places. Now, when we have a shift of 3 places on the right side, yeah, I will explain it just a second. If we have a shift of logical shift, right shift of 3 places, the value is going to get divided 3 times. So let's say if I had a number up here and I shifted to the right ones, the value is going to get divided by 2. Then again divided by 2, again divided by 2. Why am I dividing it separately? Because it says that there is a logical right shift of 3 places. It's not divided by 8. 2 divided by 2 divided by 2. Now this 2 what? 2 divided by 2 is basically division by 4, and division by 4 by division by 2 is basically division by 8. A simple method to this is a simple shortcut. Let me guys give you a shortcut. A shortcut is divide 8 by 2 raised to power number of shifts. So how many shifts were there? There were 3 shifts, right? So divide 8 by 2 raised to power 3. Now what's 2 raised to power 3? It's 8. So you need to divide it by 8. So we will write the effect as that the answer has been divided by a factor of 8. Divided by a factor of 8. Let me give you guys a quick recap of what I did in the question. In the question, it was clearly mentioned that we have a binary digit, okay? And then it says that you need to perform a logical 3 places right shift, which means that I will be shifting all of the digits to 3 spaces on the right hand side. Now this zero is going to be shifted 3 places to the right. So where will it go? It won't go up here, like it won't be up here. This is zero. This is the exact same position, right? If the question said right shift 1, then this zero would have come to this place. But no, it says 3, right? So also, if the question said right shift of 2 places, then this zero would have come at this place. But no, it says 3 places. This means that this zero is gonna go up to this very specific section. So this zero is gonna come up here, then followed by the 1 is gonna come up here. This one is gonna come up here. And if you look at it, we do have a space of 3 digits. So like this zero was at the 0 position, right? Now it's away. It's 0, 1, 2, 3. So now it's at the 3rd position. We skipped basically 3 slots. We skipped these 3 slots, and then we started the number from up here, 0, 1, 1, 1, 1, and it's just identically like this. And then after this we have these 3 numbers, right, which we don't have a slot, because if I bring the 0 up here, we don't have a place to keep it. Now what are we going to do? We are just going to ignore the numbers. Remember, ignore the numbers. If you guys are confused with this, you can watch the recording of the Friday's class. We discussed this in great detail. We're going to ignore this, we're going to ignore this, we're going to ignore this. And now we have 3 slots left at the most left hand side. We have these 3 left, right? We don't have any number because the first 0 went from the very 0th position to like after 3 places to the right, it came to this specific section, which is the 3rd position. Now what am I going to be doing up to the first 3 digits? I'm just going to be putting zeros. 0, 0, 0. Now we discussed that whenever we have a logical shift to the right hand side, we always divide the value. So a shift of 1 will mean divide by 2. A shift of 2 will mean divide by 2 followed by divided by 2. So like 10 divided by 2 is basically what? 5. And 5 divided by 2 is what? It's 2.5. Now this is the exact same thing as if I do 10 divided by 4, which gives me the same answer as 2.5. But rather than going into all of this concept, it's easier that you memorize this small shortcut, that whenever you need to multiply or divide, do it with this simple formula, 2 raised to power the number of shifts. Like you see, the question says there is a shift of 3 places to 2 raised to power 3 is what? 2 raised to power 3 is basically 8. So I will be dividing it by 8. So the answer is that the answer basically will be mentioning that the factor has been basically divided by 8. Is this clear? Yes or no? Yes, Ahmed, 100%. Yes, Saifullah, do you have a question? Yes, Saifullah, batao. Just type in the question, or if you want, I can. Okay. I guess Saifullah got his query cleared off. So this was one question I wanted to solve with you all, because we didn't do any past paper question regarding logical shifts. Now let's do one other question, right? Because we have a lot of questions to do right now from files. There's the second question. What's this about? No, let's not do this. Okay, let's do this question first. Let me just enlarge it, and then let's zoom into it, and then let's do it. Oh, we don't have the space. Let me drag it up here. Perhaps chalo pehle upar wala kar lete, phir niche wala kar lete. So question says the computer stores data as binary. Can you guys clearly see the question? Yes or no? Can you guys see the question? Okay. The computer stores data as binary. The binary number used is 1010110. Now the first question, convert the binary number to denary. Simple, easy, 1 mark. How am I going to do that? I will be writing 101011110, and I will be writing the values up here: 1, 2, 4, 8, 16, 32, 64, and 128. Now what will I be adding? It will be 128, then plus 32, then plus 8, plus 4, plus 2. Now again, mental math time, but as we are short on time, let me do it quickly on the calculator. It's giving me the answer of 174. Simple. Just write 174 up here and you get 1 on 1. Now, part B. Convert the binary number to hexadecimal. How will I be converting this binary to hexadecimal? Remember, we divide the binary number into groups of 4, which we called as what? Nibble. Now 1010 and then 1110. We make a barrier between the 4 groups, the number of groups, and then we are going to be dealing with each of them separately. 1248, 1, 2, 4, 8. Now what's this? 8 plus 2 is 10. And then what's up here? 8 plus 4, 12. 12 plus 2, 14. Remember, A is what? A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Now, 10 is basically A, so I will be writing it A, and then 14 is what? E, so I will be writing as E. Perfect, Ahmed and Sadullah. It's A, E. We got the correct answer. Again, work. Easy 2 marks. Barely taking me like a minute to solve this question. Then, a logical left shift of 3 places is performed on the binary number. Give the 8-bit binary number that would be stored after this logical left shift. Now we are shifting the number thrice to the left side. Now where's the binary number? It's up here. One, let me write it up here. 10101110. So if I make 8 slots, 1, 2, 3, 4, 5, 6, 7, 8, this 0 is gonna go where? Will it come up here? Like, will it be at this spot? No. Will it be at this spot? No. Will it be at this spot? No. Will it be at this spot? Yes. Why not the first one? The reason behind this is, like, see, look at this. The 0 was already at this position. Well, perhaps let me clearly write it above it so it's easier. This is 1, okay, slot number 0. Then this is 0. Then we have 1 up here, then 0. Then we have a 1. Then we have a 1, 1, and finally 0. Now, if I perform a single left shift, a single left shift would mean that this 0 comes up here. But the question said, no, we are performing 3 shifts, right? So when I want to perform triple shift, this 0 will go to this. So this will be 1 shift, this will be 2nd shift, and this will be basically 3rd shift. So this means that I will be basically shifting this 0 where? To this specific column, 1, 2, 3, to this section. This will be 1, this will be 2, and this is 0. And then once we get the first number, the easier method is just write the same identical digits after it, because it's going to be having the same pattern. This one won't come up here, this one won't come up here, this one will go up here. So 0, 1, then again 1, and then again 1, and then we have this 0. And these 3 numbers are just going to go into vain. We are going to be what? Ignoring them. We won't be looking at them. And then we will have 0, 0, 0 up here. So now, what will we be writing up here? 0, 1, 1, 1, 0, 0, 0, 0. Again, easy 1 mark. Easy 1 mark. Nothing complex. Let me just recopy the question up here so that we could do the other parts too. Just a moment. From files, where's the question? It was this question. Yes, this question. And now let me just enlarge it. So now we were discussing this part. We got the answer as what? 0, 111, and 4 zeros. So we got the answer as 0. Just a moment. 0, 111, and 4 zeros. Let me zoom it a bit. Okay, now it will be much clearer. Now, the question now says, tick 1 box to show which statement is true about the impact the logical left binary shift would have on the binary number. The least significant bits are lost. The most significant bits are lost. The number has been divided by 6. The number stays the same. What do you guys think? What's the answer to it? Perhaps let me just solve it. And aap log bhi dekho. What do you guys? We will be exploring all the 4 options. Now, just a moment ago, we discussed one thing, if you remember. Let me go up here. The most left digit is what? It's most significant. The most left digit is what? It's the most significant bit. Whether we have a -128 or a positive 128, the most leftmost digit is always going to be the most significant. And just like that, the most right side digit will be the least significant digit. Now, if I go back to the same example, in this, what did we lose, guys? Did we lose the most right hand side, which was basically what? A 0? Or did we lose this 1? What did we lose? We lost the left number, which was the most significant bit, MSB. Whereas, so this means that it can't be something like this, means that we didn't, the least significant bits are lost. That's the question, right? The least, but we didn't lose the significant bit. We didn't lose the least significant bit. Why? If you look at this, the least significant bit was this 0. This was the least significant bit, But this least significant bit just went up here. It's still up there. This is still up here. Like you see, the zero just shifted its position, but it's still up there. We just lost the most significant. This one was basically the most significant bit, but after the shift, we couldn't have a place for it. Due to it, we are just ignoring it and it's just got lost. So it's not A, because we lost the most significant bit. And so the answer to this is B. Easy one, easy one. But now, why is it not C and D? The number stays the same. Do you think, guys, do you think, just a moment, you look at this binary number 0, 111, and 40, and then you look at this 10, 10, 111, are both of them the same binary digits? No, right? If they are not the same binary digits, how come will they be having the same denary value? Doesn't make sense, right? So for this reason, D is also wrong. Now, coming to C, the number has been divided by 6. So remember, what did we study? When you perform logical shift right, the value gets divided. But when we perform logical shift left, the value always gets what? It multiplies. Now, if we look at this up here, it clearly mentioned that a logical left shift. So a logical left shift would mean that the value would have multiplied, not divide. So there are two mistakes with this specific C answer. Firstly, it says it's divide. No, it should have been multiplied. And secondly, when we perform a logical shift of left side to three places, we will be multiplying it by 8 and not 6. So there are two hints in this specific option to indicate that C is also incorrect, D is incorrect, and A is also incorrect. So B is the correct answer. You get B as the answer. And you just look at this. We got 1, 2, and we got 3, 4, and then we got 5. So we got like 5 marks straight forward from this in just like a minute. So easy, guys. So easy. Let's do some other questions. Let me paste one other question. I remember there was this question regarding addition of binary. So yes, we have this number question. Let me just enlarge it a bit so that you guys can clearly see it. And let me just bring this a bit down. So the question says, you have a binary number which is stored in register. Now, negative denary numbers can be represented as binary number using what? 2's complement. Important. I mentioned 2's complement. See, it clearly says 2's complement. Now the question says complete the binary register for the denary number -78. Now it's your choice. You could do it using method 1, you could do it using method 2. Let's do it using both. Or perhaps we have less time, let's do it using the 128 method. So we have 1, 2, 4, 8, 16, 32, 64, and what? -128. So you'll be putting a -128 up here, and now -128 plus x is basically -78. So x is equal to 128, which will become positive -78. What's the answer going to be? It will be 128 minus 78. It will be a 50. So we need to plot what? We need to plot a 50. How will I be doing it? Will 64 be on? No, it will be a 0. 32 on? Yes. 32 plus 16 is what? It's 48. 48 plus what is 50? It's 2. So this will be a 1. And then the other values are going to be a 0. So this is basically what? This is your -78. You're just going to write it like 10110010. And this is your answer. You get 2 on 2. Then the D part says it's the same question like this one. It's continued. So, or is it a different one? I guess it's a different one. Now the D part, two 8-bit binary numbers are given. Add the 2-bit binary numbers using binary addition. Like guys, it's so easy. Like you just get 2 marks again for this too. 2 marks again for this. 1 plus 1 is what? It's 0 with 1. 1 plus 1 plus 0 is what? Again, 2 ones, so 0 with 1 carry. Now 1 single one, 1 plus 0 plus 0, it's 1 single one, right? So 1 up here. 0 plus 0, 0. 1 plus 0, again, single one, so 1. 1 plus 1, 2 ones, so we will be having 0 in the answer and 1 as carry. Again, 2 ones, 0 up here and 1 in the carry. And now single 1 plus 0, 0, we're going to be getting a 1. So this is your added binary value, added or perhaps your answer. And you get 2 on 2 up here too. Simple marks, guys. Just see, we just in less than 10 minutes, we got like nearly 10 to 15 marks. So easy. Let's do one last question and then we can like end the class. Let's do, okay, let's do this question. Chalo ye kar lete. Let's do this question. Sadullah, can you tell me what are you trying to share? Because I didn't get what you're trying to share with us. Batado, so we could tell everyone in the class what. Okay, okay. So look at this question, guys. Now, this question is basically the continuation of this specific part, right? It's part C up here, right? We already got how many marks? Two, and then we had four, and then we had. So we had 5 marks from the first three parts, and then we get into the part D where we can score 4 plus 1. How many marks? We can score 5 up here too. So just from question number one, I'm getting 10 out of the 75 marks. See, so just like that, okay, we can have, if we do six of such questions, we get 60 out of 75, and 60 marks is the bare minimum you need to get for for an A star. But no, we are aiming for a distinction, so we need to score 75 on 75, right? We will be discussing all of these questions in such great depth so that you all can understand greatly. Now let's quickly do this question and then we will end the class. Okay, so add the two binary numbers using binary addition. Give your answer in binary and show all your work. How will I be doing it? Write the two numbers 1 1 1 0 1 1 1 0. Okay, then up here 0 0 1 1 0 0 uh 0 0 1 1 0, and then this will be a 0 to this, and then this is a 0 to this, and then this one. Make sure you directly write it beneath it so that it's easier to understand. Usually there is this mistake, so it's better if you write the numbers a bit openly like this 1 1 1, so that you can't make a mistake, because there is a large chance. Usually I personally used to mess up this thing too, so you guys should not be making a mistake. So 1 plus 0 is what? It's 1. And 1 plus 0 is what? It's 1. 1 plus 0 is what? 1. 1 plus 0 is what? 1. 1 plus 0 is what? 1. 1 plus 1, 0 with 1. 1 plus 1, 0 with 1. And then 1 plus 0, 1 plus 1 plus 0. Again, it's 0 with 1, but this one goes up here as the overflow error. This comes to the 9-bit section, right? This is overflow. Overflow. Now you will be writing it as 1 0 0 0 1 1 1 1 1. I will be checking the marking scheme to this, whether you need to write this in the answer or not. I will get back to you on this in the next class tomorrow, inshallah. I will check this again, okay? But it's better you write it like this: overflow, error, cost. Now, when the examiner will see this, there is a catch to it. Perhaps you have to ignore this one, in my opinion. Okay, I will check it and then I will get back to you on this. But for now, just ignore this overflow. Now, you look at this, you have 4 marks to it. Why do we have 4 marks when we had like 2 for the upper part? Like this part had just 2 marks, but then we have 4 for this. Why? There is a catch to it, because you get 1 mark for writing the answer, then you have maybe 2 marks for this, for adding the two binary numbers, and then you have 1 mark for identifying that yes, there is an overflow error cost. So when you indicate that yes, we had an overflow, you should just write it overflow error, or just show it up here that, oh, we had an extra one, and maybe I write it like this, overflow, and then I don't write it up here. The examiner is going to give me a solid 4 and 4. And then the denary number 301 needs to be stored. Calculate the least number of bits that can be used to store the denary number. Least number of bits. No, you just write it as an 8-bit number, because this goes to the overflow section, right? Overflow area. We won't be mentioning this. Our answer is going to stay like this until or unless they clearly mention that we have like a 12-bit binary number. Like let's say if it was a 12-bit section, then I could have written something like 1, and then I could have added just plain zeros. But because it clearly says that we are adding two 8-bit binary, it's safe to just indicate that we had an overflow error, and then just write the answer as 8-bit. Write the answer as 8-bit. But I will still recheck the marking scheme for you all, and I will confirm it to you whether the examiner wanted 8-bit or 9-bit. But it is 8-bit still. I will clearly confirm it and then get back to you later on it in tomorrow's class, inshallah. So now the denary number 301 needs to be stored. It says calculate the least number of bits. Now there is a catch to this question. Remember, we usually deal with 1, 2, 4, 8, 16, 32, 64, 128. But there is a problem. If I put 1, 1, 1, 1, 1, 1, 1, 1, the maximum I can get is like a 255. But it says 301. How will I be doing that? Now, this means I need to continue from 8 bits. This is basically an 8-bit register, but we can't store 301 in an 8-bit register. Now, what will I be doing? I'll be increasing the register size to 12-bit. How? 256, just multiple 512 multiplied by 2, 1024 multiplied by 2, and then 2048. Now, what's the maximum I need to go for? It will be a 0, 0, 0, but I need to turn 256 on, right? Now, if I turn on 256, now the answer will be a different, as in like 256 plus what number will be giving me at 301? Quickly, it will be 301 minus 256. We need to plot 45 right now, 45. So this will be a 0, this will be a 0, 16 will be a on, 32 will be on, then 16 will be a 0. 32 plus 8 is what? It's 40, 40 plus 4 plus 1, and this 0. So this binary number basically is 301. Now, what's the least number of bits that can be used to store the denary number 301? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are going to be writing 12 bits. So 12 is your answer. Exactly, Osam. Perfect. 12-bit register. So 12 is your answer to this very question. Yes, 256 plus 32 plus 8 plus 4 plus 1, exactly 250. Sorry, this will be 301. 301. I don't know why did I wrote this. Oh, okay, this 255 was the maximum range. Yeah, these are the 2023 papers. These are, I guess it was 23 that day. I took the questions from 2024 papers, and this was from May, June 2023 paper number 11, 13, and 12. I just checked these like 5 to 10 minutes before the class. I just took the screenshot and wanted to tell you. Now, you guys just tell me, are these difficult? Like, just tell me, is this something difficult? I personally always say that this is the most boring topic in the entire paper. But just let me know, even this boring topic, is this difficult? Not at all. It's like super easy, and these are the latest papers. Like, I just got easily 10 to 11 marks from nothing. Easy working, not at all. So that's all for today. We are mostly done with the topic. Inshallah, tomorrow I will try to complete the topic. We are left with some minor things, and then we will have one entire day where we are going to be doing only past paper questions. Now, the important thing is, just let me end up the recording, and then I have something to discuss with you all, and फिर उसके बाद let's end the class. Stop recording.